Hello guys. So in this video, I'm going to walk you through the code behind my nurse stress analysis and prediction project. If you haven't watched my project overview video, make sure to check out that first. In this video, I'll dive into the backend and frontend code, explain how it works and how it all comes together to predict the stress levels based on the biometric data like heart rate and temperature. So let's get started. So there are two main components on the UI. First is the dashboard, and then second is the predictions. So let's check out the backend code first. So there are two main PySpark scripts written. First is RF model and second is process data. So RF model is used to predict the stress levels and process data is used to prepare the data for the visualization. So let's start with the RF model first. We start by importing the necessary libraries like PySpark.sql, PySpark.ml, and the functions from the PySpark. The first step, the first step is to set up the set up the Spark session. This is important because Spark is the framework we are using to handle the large data sets and perform machine learning operations. So the Spark session allows us to read the dataset from an S3 bucket, in which in our case is hosted on AWS. The data contains the column like X, Y, Z, HR, EDA, temperature. So these columns we will be using, the values of these columns we will be using to predict the stress levels. Then we have read.csv. So this function is to load the dataset with the header information, and we let the PySpark infer the schema of the data. Next, we define the features and the labels. Features are the input columns, and while the label is the actual stress level we want to predict. So, next is to prepare the data for machine learning, we use the vector assembler. This this class combines all the features into a single vector column. This is crucial because most of the machine learning algorithms require the input data to be in a vector format. Then then is the random forest regressor. So for the machine learning part we are using this algorithm. It helps us to predict the stress levels based on the input features. We also use pipeline, which is a tool in PySpark that chains all the steps together for the streamlined execution. Then the data is split into 70% as training data and 30% as test data using the random split function to ensure we can evaluate the model's performance on unseen data. Then after the training the model, like after training the model, we evaluate its performance using two metrics. So first one is root mean squared error and the second is the r squared. So root mean squared error gives us an idea of how much our predictions deviate from actual values on average, and while the r squared tells us how well the features explain the variance in the target variable. Finally, we store the predictions. Finally, the predictions are rounded and cast to integer type for better readability, and then saved to the S3 bucket for the later analysis. So the model itself as well as the training and the test data are also saved for the future use. So this was all for the prediction of stress levels. Then next we have process data. So the goal of this script is to create the data that can be visualized in different charts like bar chart, line chart. So here also we do the same. We import the libraries, we start the session, we read the data from the S3 bucket, then we create two main type of visual data, line chart and bar chart. So here it is. Line chart data and bar chart data. So let's check the bar chart one. We calculate the mean of each biometric signal grouped by the label which represent stress levels. This helps us to visualize the average biometrics for different stress categories. Then we also compute the patient specific data which averages for EDA, heart rate, and temperature, which could be useful in personalized health analysis. So this was all, and again we save it, like save all the data back to the S3 bucket. So this was all for the backend part. Let's see, here is the training data, test data, and actual versus our predictions. So for this data we have used RF model script, and for the dashboard we have used the process data script. Then for the UI I have used React.js, and for all these charts I have used chart chart.js. So for UI there is nothing more much to explain, you can just refer the code. So if we see, there are two main components, dashboard and prediction. Let's go to dashboard. So this is how the code is for dashboard. There are various charts, patient data analysis, then we have bar chart, scattered plot, histogram chart. Here you can see that we get the data generated by the PySpark script from the S3 bucket, and let's check the code for the charts, how it renders. So this is the code for it. We, as I mentioned earlier, we have used, like I have used chart.js for it. So this is how the code is for the front end. So yeah, that's all. Make sure to check out my GitHub repository for the full code and the resources. And if you have any doubts, queries, any questions, or any suggestions, just mention it in the comment section. So I'll see you in the next video. Thank you for watching.